Assalamualaikum and hello everyone. So for this session, we're going to cover on a new topic, which is chapter 5, numerical differentiation. So in the previous lecture, we have learned about interpolation, in which we have solved interpolation problems by using Lagrange polynomial and also by using Newton difference method. So for this session, as I mentioned, we're going to go in for a new topic, which is called numerical differentiation. So basically, the learning outcomes for this topic is that you have the knowledge to solve basic numerical differentiation, especially by using central difference, which is widely used in engineering. You'll be able to predict the velocity acceleration value based on numerical approach, and you'll be able to implement numerical differentiation in engineering problems. So the keyword here is differentiation. So for example, first order differentiation, if you have y function, so first differentiation, you can write it as y prime x or f prime x, or you can write it as dy over dx. So this is first order differentiation. And we also have second order differentiation, in which you differentiate the y function for 2 times. So we can write it as y double prime x or f double prime x or dy over dx. Okay, so this is second order differentiation. So basically, we're going to use numerical approach to get this first order and second order differentiation by using certain method or certain approach, such as 2-point forward, 2-point backward, and 3-point central for first order. And for second order, we're going to look at 3-point central difference and 5-point central difference. So as I mentioned earlier, we have first derivative of first order, which is y prime x. So we're going to use 2-point forward, 2-point backward, and 3-point central. This one will not be covered at the first derivative formulation, such as 3-point forward, 3-point backward, and 5-point. It's not within our scope. And second, we're going to solve second derivative or second order, which is y double prime x, by using 3-point central and 5-point method. So let's start with first order of first derivative. The concept of numerical approach is that it uses Taylor series expansion. For example, from Taylor series expansion, fx plus h is equal to fx plus h f prime x plus h squared over 2 factorial f double prime and so on. So this is Taylor series expansion. In order for us to use or to solve first derivative, we will only consider up until the first order term only, because this is first order derivative. Okay, so we are not going to concern this because this is second order, this is third order, and so on. So from Taylor series, in order for us to obtain f prime x, so basically from Taylor series, fx plus h is equals to fx plus h f prime x. So what we want to find is this f prime x. So we arrange this equation. f prime x is equals to fx plus h minus fx over h. Okay, so where did I get this equation? It is from this equation, we wanted to find f prime x. Why f prime x? Because f prime x is our first order derivation. So these are the equation. And what is this h? H is what we call as step size. So what is step size? If you have a series of x and y, okay, for example, if I give you a table of x and y data, for example, x, when x equals to 0, y equals to 4, x equals to 2, y equals to 7, and when x equals to 4, y equals to 3. So what is h? H is what we call as step size, where step size is the difference between the first x and the second x. So if let's say this is our x1, this is our x2, this is our x3. So h is equals to x2 minus x1, or it can be x3 minus x2, in which, in this example, h equals to 2, because 2 minus 0, it will become 2, and 4 minus 2 is also 2. So, as I mentioned earlier, if we have x, okay, so the next value of x, the distance is what we call as h. Okay, so if our x is 2, our x plus h is 2 plus 2. So this is 4, which is our x3. And if our x is 2, so x minus h is 2 minus 2, which is 0. This one. Okay, this is just an overview for you guys to know where does first order derivative is coming from. It is basically coming from the Taylor series expansion. And what is h? H is what we call as step size. In order for you to find h, because sometimes h is not given directly in the question, so you need to find the h value by finding the step size in between the two value of x. Right, so let's look at 2-point forward for first derivative. So basically, the derivative can be shown graphically. For example, if you have x and you have the step size for the next x, which is become x plus h. So if you have x, you will also have the yx, and you have the corresponding yx plus h. In order for you to find the first derivative y prime x using 2-point forward, this equation can be used, whereby y prime x is equals to yx plus h minus yx over h. Okay, so basically for 2-point forward, you use the point data after the point of concern. So the point data is yx. The point after the point of concern is yx plus h. All right, if you're stuck, just go back to this equation And basically, in order for you to solve using this equation, you need to know what is your y-x plus h, you need to know what is your y-x, and you need to know what is your h. You can solve using 2-point forward difference. All right, so if I give you an example here, let's say we have a data which consists of y and x value. So if we want to find y prime 4, where x is 4, so this will become our point of concern, which is our 4 is our x and 3 is our y-x. Okay, so now back to this equation. You already know what is your y-x, because when x is equals to 4, the y value is 3. So now you need to know what is your h. So how do you find the h value? As I teach you earlier, h is what we call a step size. Okay, so you can do 2 minus 0, or 4 minus 2, or 6 minus 4. So our h value is 2. Okay, how do I get 2? So 4 minus 2 is equals to 2. So we have already got the value of h. We have already got the value of y-x. So the rest is y-x plus h. So if our x is 4, so x plus h is 4 plus 2, which is 6. So this is the value of x plus h, which is 6, because our x value just now was 4 and our h value is 2. So in order for us to find y-x plus h is the corresponding y values of 6, which is 4. So y-x plus h is equals to 4. And if I replace back all the values in this equation, so y prime x, which is 4, is equals to y-x plus h, which is this value. This is y-x plus h, 4, minus y-x, which is 3, over h, which is 2. So you get the answer of 0.5. Okay, it's quite straightforward and it's easy. All you need to understand is that you need to know what is your y-x plus h, what is your y-x, and what is your h value. So we can solve it using 2-point forward. All right. So now let's look at 2-point backward. So basically, if 2-point forward, we use the data at y-x plus h, but for 2-point backward, we don't use the point after, we use the point before. So if we have y-x, we need to consider the value before the point of concern, which is y-x minus h. And the equation will become y-x minus y-x minus h over h. So this is the value of or the equation that can be used to find the first order derivative by using 2-point backward. So look at the equation. It's a bit different from 2-point forward. Okay, for 2-point forward is yx plus h minus yx over h. But for 2-point backward, it is yx minus h over h, in which we use the data before the point. So let's look on the example. Again, we want to find y prime 4. So this is our point of interest whereby our x value is 4. So we can obtain our yx because our x is 4. So the y value is 3. So our yx is 3 and our x value is 4. And from the equation, we know that we need to use the data before. Okay, the data before. So this is our yx minus h. So this is x minus h. And our yx minus h is this value, which is 7.4. Okay, so how about the h value? H value is the distance between these two, which is 2. Okay, so if you are confused, let's look at this table. If you look at this table again, we've got x, we've got y, 0, 0, 2, 7.4, 4, 3, 6, 4. So if this is our yx, so this will become yx minus h, and this is the value of yx plus h, whereby this is our x, this is our x plus h, and this is our x minus h. Okay, so basically you need to know where is your x, where is your x plus h, x minus h, and the corresponding y values. So, but in order for us to use 2-point backward, as you can see, we don't need x plus h. We only need to use the point before, which is x minus h. So that's why the value of here is yx minus h, which is 7.4. Our yx is 3, and our h is the distance between these two. So 6 minus 4 or 4 minus 2, we get 2. So basically y prime 4 by using 2-point backward is 3 minus 7.4 divided by 2. And you get the answer of and calculate 3 minus 7.4. So you get negative 2.2. Okay, I hope by now you are clear what's the difference between 2-point forward and 2-point backward. So as long as you know what is your x, you know what is your x minus h, x plus h, you can replace the value in this equation. All right, that is 2-point backward. So let's look at another one, which is 3-point central. Okay, so in order for us to use 3-point central, okay, basically to use 3-point central, you need to use the data before and after the point of concern. So if let's say this is our point of concern, which is y-x, so we need to use the before and after. So what is before? Before is our y-x minus h. This is before. And we need to use the data after, which is y-x plus h. So if we look at the equation, y prime x by using 3-point central is y-x plus h minus y-x minus h over 2h. So let's say this is our example. Find y prime 4 by using 3-point central. First, we need to know what is our point of concern. Again, this is my x. So this will become my x plus h. And this will become my x minus h. So this value is y(x minus h). This is the value of y(x), and this is the value of y(x plus h). So we just replace it in the equation. So y(x plus h) is 4. Y(x minus h) is 7.4. And 2h is 2 times our h value is 2. So 4 minus 7.4 over 2.2. Sorry, 2 multiplied with 2. So we get the answer of 0.85. Okay. So basically by using 3-point central, we get the value of 0.85. So I hope by now you can differentiate the difference between 2-point forward. Okay, look at the equation in which we use the data after the point of interest, which is x plus h. And for 2-point backward, we use the data before, which is y(x minus h). And for 3-point central, we will use the data before and after, which is y(x plus h) and y(x minus h). Okay, so the rest is just replacing the value. All right, so you guys can look at the example. Okay, so you can try to do yourself. For example, 5-1, try to use the value of h equals to 1 times 10 to the power of minus 5. Try to do it yourself. Okay. So as I mentioned, this one will not be covered in our session. Okay, let's do together one example here. So given the following data, determine f prime 2 using 2-point forward, 2-point backward, and 3-point central difference formula. So if you got this kind of question, so first look at the table and highlight where is your point of interest. So this is my point of interest. So meaning that my x is 2, because it asks us f prime x. So x is 2. So if 2 is my x, 2.5 is my x plus h, and 1.5 is x minus h. Straight away, you know where is your x, where is your x plus h, and where is your x minus h. Once you know where is the value of x, x minus h, and x plus h, you can use the corresponding y value. So this is your value of yx plus h, yx, and yx minus h. So let's try to do using 2-point forward difference. So I write 2-point forward. So f prime 2 is equals to f x. Sorry, I also forgot the equation. Wait, hold on. So the equation is, for 2-point forward, is yx plus h minus yx over h. So basically, the equation is x plus h minus x over h. So what is our fx plus h? So this is our fx plus h, 13.1825 minus our fx. This is our fx, 8.3891 over h value. So h value is, as I mentioned, it's a step size. Okay, so you know that our step size is 0.5. Because 3 minus 2.5 is 0.5. 2.5 minus 2 is 0.5. And you must remember that the h value remains for all. See, in between 1 to 1.5 is 0.5. In between 1.5 to 2 is also 0.5, 0.5, and so on. So the answer is 13.1825 minus 8.3891 divided by 0.5. So I get the answer of 9.5868. Okay, so let's use 2-point backward. Okay, 2-point backward. So the equation to be used is fx minus fx minus h divided by h. So fx is 8.3891 minus fx minus h, which is 5.4817 over 0.5. 8.3891 divided by 5.4817. So I get the answer of 5.8148. Okay. So that's all for this session. And I want you guys to find by using 3-point central on your own. Okay, it's not that hard. Just use the equation f(2) is equal to fx plus h fx plus h minus fx minus h over 2h. Okay, give me the answer and submit it in the individual activities. So that's all for today. I'll see you guys on the next session. Thank you.